Hello everyone, I hope I'm live. Let me quickly check it. Yes, I guess yes. So welcome to the next session. Welcome everyone. In this particular session, let me first start these slides. Yep. Yeah. Well, these are the topics for the session: permanent magnets and the uses of electromagnets. This is what we are going to study in this particular session. But well, before I start the session, let me first introduce myself. My name is Kalyan Krishna Awasthi. I'm a physics educator at Unacademy. And as far as my qualifications, hi everyone, welcome to the session. As far as my qualifications are concerned, I'm Masters in Electronics and currently I'm pursuing Ph.D in Electronics. My area of specialization is wireless sensor networks. And I have been teaching physics since 2008-9. I mean, the best part is I have I have seen a number of board examinations for the past 12 to 13 years. So I know what sort of questions are asked in physics, and I can help you with this. This is the best part for all my sessions. And yes, I have a basic belief that if you're not able to relate the concepts with the real world, you'll never find a session interesting. You will never find a subject interesting. So that is what I try to do in all my sessions. I try to give very relevant examples, right? So without wasting any time, well, this is my code. Yes, this is my code. If you want to use it, Kalyan Live. This is my YT code. You can use it to get 10% instant discount, okay, on the over and above pricing. We have a Unacademy Champions Telegram group as well. The link is in the description box. Why am I asking you to join the link, beta? Because all the lecture notifications are there. What are my upcoming schedules? You'll get to get all the schedules there. And subsequently, once the batches start running, I'll be dropping a number of questions and everything there. So good evening, all time best. Hi Shagun. Okay. Hi Shiv. Hi Chetna. Hi beta. Hi. Hi Chetna. Hi. Okay, my voice is low, so you you want me to speak loudly, right? Yes. All time best. Okay, good evening beta. Chalo, I'll try. Hi Chetna. Hi. How are you? I've seen you quite a number of times. Yes. How are you, Chetna? How are you? Well, if you are here on this particular portal, you should rather subscribe the YouTube channel Unacademy ICSE and ISC. And Shagun, is the voice clear now? I mean, is it audible now? I mean, am I clear? All of you. I mean, I have a problem in my throat. I'm not having a very good throat, but maybe I'll try to speak loud, right? So well, if you haven't subscribed it yet, go for the subscription part. We are aiming for 1000 subscribers and we need your support for that. And once you subscribe, don't forget to click the like button and the bell icon, right? I mean, as soon as you click the bell icon, you'll be updated with all the notifications, right? Okay, so let's start the session. The very first thing, okay, before starting the session, let me quickly brief you about this Unacademy prodigy. I've been telling you about this in all my previous sessions as well. This is a test happening for class 7 to 10 students, and the best part is that you can enroll for it absolutely free. I mean, you won't have to shell even a single buck for that. The very first date is 23rd Jan. I mean, the test is happening on 4 dates, and this is the very first date, and the timing is from 12 p.m. to 1 p.m. Okay, and the links, the details are there. Okay, Chetna, you have subscribed. That's good. Okay, this is the topic for today's session. We'll be discussing permanent magnets and the uses of electromagnet, I guess. Hi Krish, how are you? You have changed your name, I guess. Yes. This time around you have changed your name. Yes, Krish. Last time around you came from your mother's ID. You told me in the previous session. Okay, that's great. So this is what we are going to discuss in the particular session. I just need a hi from everyone who is present in the session so that I get to know. And the session might be quite interactive in that case. I mean, if I'm okay. Hi Adnan. Okay, okay. Okay. Okay, fine. Shagun is there, Krish is there. Okay. Bhav, Daksh, are you there in the session? The ones who were there in the special class, I mean. Okay, fine. See, the very first thing, what hi Chetna. The very first thing is what a permanent magnet is. I have told you. We have had a discussion about this in the earlier sessions as well. Permanent magnets are naturally occurring magnets. I mean, we don't make them artificially, they are naturally occurring. And where do they occur? I mean, it's a natural phenomena, and the very first magnet was found in Magnesia. It was a place in Asia Minor. And you'll be thinking, why is it, sir, repeating this particular term again and again? So that you get to establish a connection with the word magnet. From this particular word magnesia, we have derived the word magnet. But there were few problems with permanent magnets. I mean, although it sounds as if, yeah, it sounds as if permanent. I mean, uh, it might be something cool that they're exhibiting permanent magnetism, but they do have some problems. And the very first problem is their irregular shape. I mean, they're not having a regular defined shape. And why are they not having a regular shape? Can anyone tell me in the chat box? Why don't they have a regular shape? See, they are natural magnets. They occur naturally in nature, and that is why they are of irregular shape. I mean, they can be found in any damn shape. But what's the problem with the shape? I mean, it's okay if they are of irregular shape. The problem lies in the commercial usage. I mean, if a magnet is of irregular shape, you cannot use it in commercial appliances. I mean, it's not possible to use it. And once the usage is compromised, the magnetic property is of no use. Chetna is saying that because they are natural. Yes, exactly. Very good. They are natural. They are natural. That is why they are of irregular shape. I mean, the shape is natural. Okay. And the second part is their magnetic property is very weak. I guess Muhammad Adnan Ahmed, you were asking this. Natural magnets and permanent magnets. Yes, you had this problem in the previous session that we had. See, although they possess permanent magnetism and they occur naturally, but the problem is that their magnetic strength is not that strong. I mean, they're not strong magnets. Although the occurrence is quite natural, but they do not exhibit strong magnetic properties. And for applications, we do need magnets which exhibit strong magnetism. I mean, if they're not exhibiting strong magnetism, you cannot find a commercial application. I mean, if you wish to create a strong magnetic field, you cannot create a strong magnetic field with a natural magnet. Yes, although we do have a provision, we use steel as a core to increase the magnetic property, but not to up to that particular extent. So this is the problem with the natural magnets. Two basic problems: one is the irregular shape and the second one is the weak magnetism. Okay, right? I've seen I've told you about this provision. There is a provision to increase the magnetism, but again, Krish, they are, they are naturally occurring substance. I mean, see, uh, the question is very obvious. I mean, the nature has given them magnetism, but we want magnets for the applications where we need to create a strong magnetic field, like Shagun asked in the previous YT session. Shagun, you remember you have asked me a question, why do we use magnets in speakers? I guess you asked me this question. Yes, I guess you were the one who asked this question. Yes, I guess no one else was there in the session. Shagun asked me a question, why do we use magnets in speakers? Now see, I am answering your question through an example. What we need in speakers is we need to create a reverse magnetic field so that the two magnetic fields interact and they create vibrations. Okay. Now, if I'm using a natural magnet, it it will have a limit to its magnetic property. Why? Because it has its property naturally. I mean, nature has given natural magnets its magnetic property, but for applications at times you need strong magnet. For example, like you're in class 9th, maybe in class 10th, some ninth next class you have, I mean, which class, Shiv, which class? The special one or the plus one? I mean, the special one or the plus one? I will be showing a slide during the session where I'll be telling you the details of all my upcoming plus classes. Shiv, just attend the session. You'll get to know when I'm having my special class and you can attend that particular special class. Okay. I'll tell you. The slide is incorporated in this particular session. Just stay in the session. Just wait for some time and you'll get to know. Right? See what I was talking about in class 10th, maybe we'll study, I mean, you'll be studying, electric motors and AC generators. I mean, those who are class 10 students, they might have this part in the syllabus, where you put an armature coil between two strong magnets, NS. Now here you need a strong magnetic field. I mean, you cannot use a natural magnet to create this strong magnetic field. Okay. Yes. Krish, you cannot use a natural magnet to create this strong magnetic field. Is it clear? So that is why we, went for a different kind of magnet that we called electromagnet. Okay. Now, this permanent magnet has few basic things, a few distinctive properties as well. I mean, they don't lose their magnetic property. Okay. They don't lose their magnetic properties. Now, this is the difference between an electromagnet and a permanent magnet. But before that, I would like to ask you, what is an electromagnet? Can anyone tell me what is an electromagnet? Anyone in the session? I mean, we have had a session on this. The last session was on electromagnets only. Can anyone tell me what is an electromagnet? Yes, Krish. Time management. Okay. Maybe in the special class? Yes? This time you got it correct. Okay, what is an electromagnet? Okay, Shagun is saying a magnet that is made by electric current. Okay. Others, I want replies. Okay, Krish is saying weak magnet. No, it's not a weak magnet. Krish is not a weak magnet. Solenoid is an electromagnet. Okay. Okay. I mean, it's a bar magnet. Bar magnet and solenoid are, analogous to each other. Okay. I mean, I want a direct answer. All time best, I need a direct answer. I mean, what is an electromagnet? In a very simple language, how will you define an electromagnet? See, an electromagnet is an artificial magnet. Okay. It is an artificial magnet, and since it is an artificial magnet, so we have that leverage of having a strong magnetic field. Yes, we can create a strong magnet out of a electromagnet, strong magnetism. And yes, Shagun has replied correctly. It is no, Krish and Shagun both have replied correctly that it is a temporary magnet. I mean, what actually happens, let me tell you how this is formed. Let us suppose, I mean, what happens, this is RH, this is E, this is key, we pass a current here. Okay. And When we pass a current, this coil gets magnetized, and because of the electric effect of current that we have just studied in the special class a while ago, because of the magnetic effect of current, a strong magnetic field is generated. Okay, but the problem is I mean, if the current stops, there is no magnetic property. The magnetic property ceases immediately. The magnetism is because of the passage of the current. So that is why we at times we call them temporary magnets. I mean, they cannot be permanent magnets. Okay, you should rather call them temporary magnets. Okay, is it clear to everyone? Electromagnets are temporary magnets. And why are they temporary magnets? Because their magnetic properties last as long as the current is flowing. As soon as the current ceases, no magnetic property is exhibited, right? Yes. Now, since we have the facility of changing the current, in case I increase the value of current, what will happen? Who will tell me? No, Chetna, electromagnet in electric belt. Yes, we use electromagnets in electric belt. Yes, you're right. What will happen if I increase the value of current? I mean, in this particular coil, if I increase the value of the current, what will happen? Anyone in the session? Yes. What will happen if I increase the value of current? Yes, all time best is correct. The magnetism will increase, right? See, the magnetic property was induced because of the flowing current. I mean, if we increase the value of the current, obviously the magnetism will increase. Okay, so in electromagnets we have all the facility to increase the magnetic effect. Yes, see the application part. I mean, that is why electromagnets are finding huge applications, right? Yes. Now, can we reverse the magnetic field in an electromagnet? Can anyone tell me? I mean, can I reverse the magnetic field? I mean, if I'm having a magnetic field from, say, A to B, this is A, this is B, can I reverse the magnetic field from B to A? Anyone? I mean, it's a very logical question. I hope many of you will be able to answer it. It's very logical. Okay, Shagun is saying yes. Chetna is saying yes. Okay, who? What about others? Krish, all time best. What do you say, guys? I mean, can I reverse? Okay, Krish is saying yes. Okay, and who else is there? Let me see. Muhammad Adnan, yes. What do you say? I mean, can we do so? Okay, now tell me, how can we do this? I mean, how can I reverse the direction of the magnetic field that is created? How can I do this? Come on, quickly. I know you can tell me. I mean, you all are smart enough and you have been attending all the sessions. In case you have missed any of the YT sessions, the lectures are very much there. You can just go and watch the lectures. Don't forget to leave. I mean, don't forget to watch any lecture. I mean, everything is connected. Come on, how can I increase? I mean, what happens if I reverse the direction of the current? What will happen? Yes, Shagun is absolutely right. If I reverse the polarities of the battery, the direction of the current will change. Yes, all time best is also correct. By changing the you are awake, right? ATV, you are awake. If I'm not wrong, I mean, I'm very bad at remembering names. Yes. Polarities can be changed. Okay, Krish is saying that the polarities can be changed. Okay, that's great. What else can be done? Fine. So as we change the polarities of the cell, I mean, let's make negative here and negative here and positive here. The direction of the current changes. Okay, I'm sorry, I got your name incorrect. No issues. I mean, the direction of the current changes, and as soon as the direction of the current changes, the direction of the magnetic field is reversed. So we can change the direction of the magnetic field. Okay. Yes. And an electromagnet needs to be demagnetized as well. I mean, how many of you know this? Demagnetizing an electromagnet is again a very important constraint. I mean, you cannot have an electromagnet that takes time to demagnetize. You know, we have discussed this in the previous class that was called retentivity. Yes. How many of you remember this? We have discussed two terms: permeability and retentivity. I hope you remember this. Yes, all of you who were present in the special classes. So it is very important for an electromagnet to be capable enough to, demagnetize. I mean, at times we require the electromagnets to be demagnetized as well. Okay. Otherwise, they will not find a proper application. That we'll be discussing this in the electric bell part, right? Okay, fine. It's very easy. I guess few of you have seen this question in the previous session as well. I want the answers quickly. I have given you the reason as well. I mean, Krish, what do you want me to explain again, Krish? I mean, just elaborate on it so that I can repeat. Okay, Chetna is getting all time best is saying A. No, beta, no, it's not A. It's not A, beta. It has to be B. See, whenever this word uniform magnetic field comes, you have to be very precise. Yes, Chetna was right. I mean, it has to be B. A uniform magnetic field is always represented by parallel equidistant lines. I mean, it is analogous to Earth's magnetic field, right? I mean, if I ask you to draw Earth's magnetic field or represent Earth's magnetic field, how do you represent it? You represent the Earth's magnetic field through parallel lines which are equidistant, right? Yes? This is how we do this. Okay, this is how we do it. So the correct answer should be parallel. Okay, this is very easy. I mean, everyone will be able to reply. I want the reply instantly, quickly. Come on. What should be the answer? Chirag Mehta, 6th day, is saying, hi Chirag, how are you? Shagun is saying A. Krish is saying A, okay. Chirag is saying A, great. Chetna is saying A. Okay, Chetna, it's A. Yes. Right? So, this was an easy one. I mean, this was an easy one. Okay. This was an easy one. Okay. Now, tell me this. This is a new one. Just think before replying. See, in all these sessions now we are... Okay, Krish, I got your question. I'll be explaining permeability. Not an issue. Let me finish with the session. I mean, in the end of the session... Okay, Shagun is saying C. Let me see what others are saying. Chirag, what do you say? I mean, what's the answer? Krish, Chirag. Just see the question. C. Chirag is saying C. Krish is saying C. Okay. Shagun is saying C. Chetna, beta, what should be the answer? Okay, Chetna is saying C. Yes, C is the correct answer. Okay, C is the correct answer. I mean, the polarity is maximum at the D. No, beta, no all time best. D cannot be the correct answer. C. Just remember this with a very basic example. You know, the magnetic field lines are very dense at the poles, right? At poles, you'll find magnetic field lines very dense. And as you move away from the pole, you'll get to see that the lines become scarred. I mean, they, the frequency, the density of the line decreases. Why? Because the intensity of the magnetic field is maximum at the poles, okay, and within the within the magnet, the magnetic field lines move from south to north. Outside the magnet they move from north to south, and within the magnet they move from south to north, and this is how it goes. It is maximum at the poles. Okay, all time best, you got this? Yes. Yes, I need a thumbs up if you have understood this, all of you. Chalo, let me quickly brief you about the batches that we are having on Unacademy. The Mavericks batch is for ICSE students, in which the delivery is in English. That is the best part. You'll get to, get the content delivered in English. And the batches have already started from 17th of Jan rather. And, if you haven't enrolled in the batch yet, this is the right time. You can very much enroll in the batch. You can use my YT code, which is Kalyan Live. This is my code. You can use this code to avail 10% discount rather. Okay, and these are the faculty members who will be teaching. In case you wish to opt for a Hindi mode of delivery, you can rather subscribe for this Udan batch. Okay, we have this batch Udan, in which the mode of delivery is Hindi, and these are the faculty members who are teaching in Udan batch, right? Now let's see the uses of electromagnet. Who can tell me the uses of electromagnets without just looking at the slide? Who can tell me the uses of electromagnets? I want the answers in the chat box. Let's see. It's a very generic topic. You tell me few important uses, and then I'll explain you the working of electric bell. That will be the end of the session. Okay, so okay, apart from electric bell, yes, Shagun is saying electric bell, all time best is saying electric bell. I'm asking, apart from electric bell, where else can you find an application of okay, Krish is, but apart from electric bell, okay, I got your point that electric bells are is a place where we use electromagnets, but anything else apart from electric bells? Okay, telephone. Telephone. Where do we use in telephone, Krish? Can you elaborate on this? DC motor. DC motor. If you are telling me a particular application, you have to elaborate on this as well. Where do you use the electromagnet in DC motor? Used by, medical applications, Shagun, yes. All time best. Where do you electric fans? Okay. It. It's not necessary that you tell me the uh, name of an appliance only. I am asking about general applications. Let it be quite generic. Chetna is saying toys. Okay, just go through the slide. If you have to lift a very heavy iron scrap, you can very well use an electromagnet, right? The iron will get attracted towards it, and it will easily be lifted. Yes, can we use it that way? All of you, can we? I need an affirmation. Can we use it that way? Yes. It's a very basic thing. The same goes with loading furnaces with iron. If you have to load a furnace with iron, you can lift the iron using method 1. Okay. For separating the iron pieces from debris and ores. This finds quite a lot of application in metallurgy. Yes. You have to separate the iron debris from the ores. There you can use a very strong electromagnet rather. Right? This is a medical application. Yes, if there is a iron nail stuck somewhere, you can rather use an electromagnet to pull it out from the body. Okay. bells, telegraphs, electric trams, etc. This is what you guys were talking about. Okay, now let's see the electric bell. I mean, the most important part. How many of you know how an electric bell works? Okay, how many of you know how an electric bell works? Just send a thumbs up so that I get to know. How many of you know how an electric bell works? Yes, how many of you? Okay, Shagun knows how an electric bell works. Okay, who else knows how it works? Okay, okay, Chetna knows how it works. Great, that's great. And okay, fine. See, let me first brief you about the parts that are present in an electric bell, and then we'll be, seeing how it actually functions. Just a second. Yes, this is how it works. Actually, let me quickly brief you about this Unacademy feature, and then we can get back to the functioning of electric bell. Right? See, first of all, this is my code, Kalyan Live. If you wish to subscribe any of the plus courses, you can very well use my code. Once you're using my code, you'll be getting a 10% instant discount over and above. Okay? Okay. Chetna wants. Okay, fine. Is that okay? Right? Okay, see. The best part is that you get to access the. I mean, we are left with the functioning of electric bell. I mean, don't leave the session in between. I'll be explaining the functioning as well. So what I was telling you that you can learn at your own comfort. I mean, you have the unlimited access to all the course content. You can anytime go through the content. You can watch the videos. Right. So this is the best part, and you get to learn from the top educators. I mean, you have already seen the quality of teachers that they have at Unacademy. I mean, everyone is the best in its own regard, in its own particular field. So I mean, it's not easy to be an Unacademy educator. The recruitment process is quite tough, so you will never get a teacher who is not good. So I mean, that's perfectly okay. You don't have to bother about the quality of teachers that they are giving. Okay. And the best part that I find is the regular doubt clearing sessions. I mean, every fourth session in a plus class is a doubt clearing session. You have that facility to ask whatever question you have related to that particular topic. This adds a lot of value to this particular section, right? And well, the course is designed quite elaborately. We cover each and every topic of the syllabus. The back end process is very good. I mean, none of the topics is left. It goes through a number of checks so that it is ensured that the students don't have to suffer. I mean, it's not like uh, I can design a course on my own and teach anything. I mean, there is a protocol that has to be followed, due to which the courses are extensively covered, the syllabuses are extensively covered, none of the topics is left. I mean, if you have seen all the lectures in the plus class, you have seen that we follow accordingly. I mean, as per strictly as per the syllabus recommended by the council, right? Of late they have started with this mentorship and guidance facility as well. You can very well download the study material in the PDF form. Once the class is over, you can download the slides, right? They have the provision for this practice test. There are live test series. I mean, this is great. You get to participate in a test series live. I mean, a number of students simultaneously take part in a series. This adds value, right? This adds value. And the best part is that you get to learn in a batch course. I mean, there are separate batches targeting different courses. I mean, separate batches for 9, 10, 11, 12. So this is how organized they are, and that is why I should rather recommend you to go for the Unacademy subscription, right? And yes, don't forget to use this code Kalyan Live. It will help you get an additional discount of 10%. Okay, see, just look at the pricing. Just look at the pricing. and that too an added advantage of 10. I guess the last three ones are not visible, so let me write. It's 1500 per month, and this is 1300 per month, and this is like 11 to 5 per month. I mean, if you're opting for a 12-month subscription, per month will cost you only 11 to 5, and they are having an offer. If you're opting for a 12-month subscription, you will be getting 3 months absolutely free. I mean, in the pricing of 12 months, you'll be getting a 15-month subscription. I mean, you can avail this offer for any duration above 12 months, right? So if you're opting for 36 months, it will be 39 months, right? This is the best part. And yes, you can use my code. Once you use my code, you'll be getting 10% additional discount. That adds value, and it adds to the saving part as well. Yes. Yes, it's Kalyan Live. KALYAN LIVE. KALYAN. That's my name. And LIVE, live, right? Kalyan is my name and the code is Kalyan Live. I'm repeating it again. It's Kalyan Live. You can use this code to avail 10% discount. Okay. Now, that is what you are asking about. See, this is the detail of my upcoming special classes. I mean, this happens to be a YT class, and the subsequent classes will be a special classes. The next special class is falling tomorrow, 21. See, the topic will be uses of electromagnetism. Again, here I'll be elaborating the use of electric well. In today's particular session, we'll be just rushing on with it. But tomorrow I'll be elaborating on this electric bell. And from 22nd, we are starting with this sound. See, this is the sound part. We haven't started it yet in any of these sessions. I mean, you get to learn this in all these special classes. So what are you waiting for? You can just enroll for this special class. Right now, you can enroll for the special class. You can, click for the notify me. As soon as I'll be live, you'll get to know, right? This, just take a snap of this particular schedule and make sure that you enroll for every special class. Okay, all of you who are present in the session, don't miss a special class. It's absolutely free. In case you find the content worthy enough, you think that the mode of delivery is good, you're finding it interesting, you can go for plus subscription either. And this is the code that is to be used in that case, Kalyan Live. Okay, so if you haven't attended any of the plus classes, any of the special classes, let me quickly brief you with the special features that the special classes is offering. Right? The very best part is that it offers a live real-time interaction using chats and emojis. I mean, we can chat on a lively basis. I mean, you can just drop in your comments and we can, talk that way. We can address the doubts. For addressing the doubts, we have got this special tab as well. See, this is a tab. What you have to do is you just have to click on that particular tab and write your query like, what is electromagnet? And you just have to send it to me. And as soon as you send it, I'll receive it. And once I open it, it will be visible to everyone on the screen with your name. For example, if Shagun asks a question, or for that matter, if Chetna asks a question, it will be visible to everyone. And I'll be replying on that particular part then and there. Okay. This is going to be the best part. And we have this leaderboard as well. I mean, of all the quizzes that have been, that take place in a particular session, by the end of the session, we have this facility of displaying the leaderboard. I mean, who was leading all the polls. I mean, for example, if there are 5 polls, so the marks will be displayed. I mean, how many times you got it correct, maybe say 5 out of 5, and what was the average time. I mean, how much time did you take on an average to reply. This is again a very fascinating kind of a thing. Okay, so it generates a sense of competition amongst the students. This is the best part of this special feature. And well, if you wish to watch any of my special classes, this is how you can do it. The very first thing that you have to do is just download the Unacademy's learner app. make sure you download the learner app, not the educator app. Okay, the educator app is for the educators, for the teachers. Just download the Unacademy learner app, install it, click on the get started, write your mobile number XYZ, write your name, for example Chetna, you can write your name, click on the continue, and you'll be diverted to this particular portal. Here, class 6 to 12. I mean, you have to click on this part. Hopefully, you are a K-12 student. K-12 is class 6 to 12, and you can select your goal here. I mean, it might either be ICSE 9th or ICSE 10th. Okay, so you just have to click on this particular tab. I mean, just select your goal, right, prefer your language since you're an ICSE student. So, in all possibility, you will be going for the English language, right? Chalo. Now, before the recap part, let me quickly sum up. So, these are the the parts of an electric bell. We were discussing about electric bell, right? Your question is, why is soft iron generally used as the core of electromagnet? Because of its okay, I mean, you these are the reasons: permeability and retentivity. This is the reason why we use soft iron core. Okay, it has high permeability and low retentivity. Okay, now let me explain you. I mean, this was the your question, Krish. What do you mean by permeability? Now see, let me explain you with this particular thing. For example, this is soft iron core, right? You're getting my point. This is soft iron core, or maybe anything else. And these are the magnetic field lines, magnetic flux density that we call. These are the magnetic field lines which are incident on it. Now, for example, five lines are incident. Five lines are incident. Okay. Let us suppose that five lines are incident. And five lines pass. I mean, whatever has been incident on this, all the lines pass. Now, this is case 1. Let's see case 2. Five lines are incident and three lines pass. Let's take another case 3. Five lines are incident and 0 pass. Now tell me, which is the best case scenario? Krish will tell me. Yes, I'll be explaining both the terms. Which will be a better case scenario? Krish? Which is a better case scenario? I mean, out of 5 incident lines, all the 5 passed. Or in the second case, out of 5 incident lines, 3 passed. And in the third instant, all of the 5 lines, none of them passed. Which is the best case scenario? And I mean, what do you expect from a core? I mean, you are using a core in an electromagnet, and what do you expect from it? I mean, you expect it to pass all the lines, or you expect it to pass some lines, or you expect it to pass none of the lines? What do you expect a core to do? What do you expect a core to do, Krish? It's okay. I mean, it's a very general question. What do you expect a core to do? I mean, you expect it to pass all the lines? Yes or no? Yes or no? Now, whether or not a particular material is passing all the lines, it solely depends on the type of material, right? I mean, there are no external parameters that can affect whether a material is allowing the lines to pass through it or not. It solely depends on the type of material, right? Yes, it solely depends on the type of material. Is it clear to you? And type of material means internal arrangement. I mean, how are the electrons and molecules arranged within the material will decide whether or not the matter or the material will allow the electric field lines or magnetic field lines to pass through it. Yes? Yes, Krish? So now tell me, soft iron core. See, iron are ferromagnetic. I have told you earlier as well. Ferromagnetic. See, let me again brief you about this. There are three types of materials. Ferromagnetic, paramagnetic, and diamagnetic. This classification is based on the internal arrangement of the magnetic dipoles. I'm using a heavy word, magnetic dipoles. We won't be studying what a magnetic dipole is, but just assume that there is something with there is something within the material which arranges itself, and because of that particular arrangement, the material either facilitates magnetic property or it opposes the external field, right? Now, in case of an electromagnet, for example, this is a horseshoe magnet that we are using in an electric bell. What are we expecting? I mean, what do we expect? I mean, do we expect it to magnetize slowly or we expect it to magnetize quickly? What do you expect? I mean, how many of you are in the session? Just raise your hands, or maybe yes, thumbs, so that I get to know who is present. I mean, I can see few of you, but only Krish is replying. Fastly, okay. Shagun is saying that, okay, Shagun is saying that we expect it to magnetize fastly. Yes, exactly. We expect it to magnetize fastly. That's great. So, Kat, so you asked me about permeability and retentivity. So, permeability is, the ability of a material to allow magnetic field lines to pass through it. It is always desirable to have, you know a material with high permeability. I mean, if the permeability is low, how can it facilitate magnetism? I mean, it's not going to facilitate magnetism. You're getting my point? Yes or no? Yes. I mean, it's not going to facilitate magnetism. No ways. Yes. All of you. Yes or no? And what is retentivity? This is what you asked. Retentivity. Retentivity is like, I mean, in applications, like magnetization is important, likewise demagnetization is also important. See, if on magnetization the armature is attracted and attached to this brush and this hammer strikes the thong, so it is expected that the magnet should demagnetize as well. I mean, if the magnet takes time to demagnetize, this particular rod, this armature, it will not be detached. And if it will not be detached, it will not return back to its original position. Okay, it will not return back to its original position. So demagnetization is again a very important constraint. Okay, so that property is called retentivity. So let's quickly see what are the important parts. I mean, there is a horseshoe magnet having a soft iron core, and this was your question, Krish, I guess. Why did we use soft iron core? I hope you got the answer. Yes, Krish, you got the answer, beta. Then we have an armature, a hammer, gong, metallic spring strip, SS, switch, battery. See, this is how it happens. I mean, just see this. Let me first delete the previous one so that you can kind of see things. Yes, this is a hammer. Yes. Okay, I knew. I mean, I have this in the slides. You have, the question is should be slightly modified. I mean, the question should be, sir, can we use AC current? This should be the question. I mean, in DC motor, sorry, in electric bells, can we use DC AC current? Is this you want to ask, Krish? Yes. Yes, is this you want to ask? Okay, fine. See, let's. Let me. Yes, this is an AC source. You know how an AC current is represented. भैया इसको I mean इसको इंग्लिश में if you could write, आलोक वर्मा जी, I'll help you with it. I'm not very good at this Hindi. You can write it in English. I'll reply. Alok Verma, can you, send me, write your question in English. I don't know Hindi. Dhanatmak, Visthapan, and I am sorry. Just write it in English. I'll I'll reply. See, this is an AC current. See what it does. It attains a maximum value periodically, and then it gives a negative value. Okay. I mean, Mr. Alok Verma wants to ask the difference between a horseshoe and a U-shaped magnet. Is it? No problem. No problem. Okay. Different displacement here in electric bell. Come on. It's like in one of the previous sessions, that why are silk industry located at the seashore? It's like this. So let's first address the question. For example, if you are using an AC source, okay, see in this particular circuit you have seen a DC source. This is a DC source, right? This is a DC source, and your question is, what if we use an AC source? Let us use an AC source. What will happen in one of the polarities? When the AC attains its maximum value, what will happen? It will be magnetized. Okay, it will be magnetized, and once the polarity changes, what will happen? In the negative cycle, the polarities will reverse. Yes, just see. In one cycle this will be plus, and immediately in the other cycle this will be negative, right? Why? Because we are using AC. Okay, you're getting my point. MCQ, we have done MCQ, Chetna, in the beginning. We have done this in the beginning. So see what happens. This is polarity. This is the max polarity. This is the min polarity. Okay, right? What happens? As the polarities changes, the electromagnet frequently magnetizes and demagnetizes. Okay, so it's not that the bell will not ring. The bell will indeed ring. The bell will ring with AC. This question has been asked a number of times. So let me clear it once for all. If you are using an AC source, then also the bell will ring. Okay, why? Because the basic principle is the magnetization and the demagnetization. Okay, you're getting my point, all of you? Yes or no? Okay, Alok, just wait. Let me finish with this. I'll be replying. Don't worry. हमारे दरबार से कोई ऐसे नहीं जाएगा. If you have asked a question, you will get an answer. Just, is it okay? This was a relevant question. Yes, is it okay? I need a thumbs up if you've got this. Okay, Krish has got this. Now let's check Mr. Alok's question. Maybe in the next session, Chetna, we'll have more MCQs. Alok, you're there in the session. Just say yes or no, so that I can reply. Alok, you're there in the session. You have asked the difference between positive and negative displacement. Although the question is out of context, but see, since you have asked, let me reply. Can anyone tell me? Positive displacement means the body. Okay, the positive displacement means, for example, this is Alok. Mm, 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 mm. This is Alok's school. Okay. The shortest distance is displacement. Right, Alok? The shortest distance is displacement. Right? Okay. Now Alok is moving from his house to school. I mean, this was the reference point. You have to have a reference point if you're talking about positive and negative quantities. If with respect to reference point, Alok is going from his house to school, I mean, in the direction of the displacement, then we'll call it a positive displacement. In case he's returning from its school, is just a sense, positive and negative. The displacement value the displacement value though will be same. Okay, I mean, it's not that the displacement value will change, but for this particular displacement, if you are returning to your reference point, I mean, the motion started from your house and you are started moving towards your school. So this was the sense of motion. This is positive displacement. When you return back, this is negative displacement. I mean, in laws of motion, we take positive and negative displacement this way. And the other important part is, if you draw the distance time graph, I mean, this is good. If you remember, you're in which class? 9th, 10th, 11th or 12th? Alok, you're in which class? Okay, you don't want to tell this. So you might get the positive and negative values from the graphs as well. Okay. So let's quickly get a recap of what we have studied. Okay. I hope you got the logic clear. This is what we have covered in the Chetna, you participated in these polls. Okay, great. That's great. Chetna, you participated in these polls or not? You can attend all the sessions if you feel like. Okay. Okay, it's a question. If you want to participate in the polls, Chetna, you can. I mean, here we can have quizzes, not polls. For polls, you have to attend these special classes. We have had 7 to 8 polls just a while ago. You can tell me, how can we increase the strength of an electromagnet? I mean, if you want to answer a question, I mean, anyone can tell me, how can we increase the strength of an electromagnet? Come on, quickly. We are not left with much time. How can we increase the strength of an electromagnet? Any one of you in the sessions? Yes? What else? Okay, what else? I mean, increasing the current is one method. Yes, very good. By increasing the number of turns. Okay. So, well, by increasing the electric current, okay, Alok, and by increasing the number of turns as well. I mean, both ways you'll be able to increase the strength of the electromagnet. See, soft iron is placed when you are forming the electromagnet. I mean, okay, once the soft iron is placed, then only the question has been asked. Okay, all time best. Soft iron, your answer is technically correct, but my question was, the electromagnet is already there, and now you wish to increase its strength. I mean, you won't be replacing the soft iron core. I mean, since you already have an electromagnet, so obviously it would had a soft iron core. So that's out of context. I hope, Alok, your doubts are resolved. All of you, I hope you found the sessions interesting. Yes, all of you. Need a thumbs up. Just take a pic of this particular slide. It has the details of all my upcoming special classes. You can attend these classes and decide if you want to go for it. Bye, Chetna. Bye, beta. Hope to see you again in the next special class. You can take a pic of this slide and attend the special classes. That's all from me in this particular session. Hope to see you again in one of the sessions, right? Yes, okay, fine. Thanks everyone. Okay, Alok, I hope the problem was solved. I mean, समझ में आ गया ना, Mr. Verma? Next class of EMI, electromagnetic induction. Bye, beta. Bye, everyone. Bye, everyone. Hope to see you all again very soon, maybe in the next class. Yes? कल वाईटी क्लास, एक मिनट बेटा, लेट मी सी. आज है तो शायद कल नहीं होगा. आई मीन कल नहीं होना चाहिए. ओके आलोक, ग्रेट. कल वाईटी क्लास है, 10th का वाईटी क्लास है. देयर आई विल बी डिस्कसिंग डीसी मोटर्स. आई मीन वेरी इंपॉर्टेंट, डीसी मोटर्स. तो Mr. NDA, if you want, you can attend that class. I mean, DC motors is an important topic for NDA preparation as well. It's a very generic topic. So I'm ending the session as of now. Thanks everyone. Good night. Stay healthy. Stay safe. Please, don't move out of your houses without any reason. Take very good care of yourself. Thanks. Good night. Good night. Good night.